Hello. Okay, good afternoon.
Resonance amplitude.
Huh?
Sir, resonance amplitude.
Resonance amplitude. So we started from resonance. I told you about SHO, DHO, forced, then resonance, na?
Yes, sir.
Okay. So what is resonance? We can say applying the frequency omega. Body has its own frequency omega 0. Both are equal. So that is omega is equal to omega naught. That is known as resonance. So how many conditions are there for resonance?
Three conditions.
Three conditions.
So what are they? Tell me.
Omega equal to
Omega is
omega
equal
naught.
to omega naught.
Amplitude will be
Amplitude
maximum. Beta is very much smaller.
Okay, that means the damping factor will be very small. Okay. So after that we discuss the analytical treatment, and we got omega is equal to S here. Let's show you. Okay. So here S omega is equal to omega naught, amplitude will be maximum, beta is very small, and we have done the analytical treatment. Okay, by taking the amplitude of the forced oscillator, we got omega is equal to omega naught square minus 2 beta square. Okay, which is equal to omega r, and what will happen when beta tends to 0? Omega is equal to omega naught, which is equal to omega r. Am I right?
Yes, sir.
Yes, sir.
Yes. So we have done omega is equal to omega naught, which is equal to omega r. And this omega r is known as your resonance angular frequency, and fr is known as resonance frequency, which is equal to omega r divided by 2 pi. Okay. So after that we discuss the resonance amplitude. What is the resonance amplitude? The amplitude at which resonance occurs. Yes,
Yes, sir.
Yes, sir.
the amplitude at which the resonance occurs is called resonance amplitude. That is AR or A max. Okay. So we have done. Lastly, you see, this is the expression for the amplitude. Here only we have to substitute omega. Omega is equal to omega what? Omega will be omega r square, because at resonance amplitude will be maximum. Omega becomes omega r. Putting the value of omega r square, we got the last expression is A max is equal to F0 divided by B omega naught square minus beta square under root. Okay, am I right?
Yes, sir.
Yes, sir.
I can say A max, right? A max is inversely proportional to the B. A max is inversely proportional to the B. Okay, so that means the resonance amplitude is inversely proportional to the damping constant. If damping factor will be more, amplitude will be less. If this will be less, it will be more. Okay, as we have taken beta is very small, so amplitude will be maximum. Already we have discussed. Okay, Ujela. So how the resonance, if question will ask short question, how the resonance amplitude vary with damping coefficient or damping constant? Your answer will be inversely proportional to the damping coefficient or damping constant. Understood? Understood or
Yes, sir.
not?
Yes, sir.
Yes, sir.
Okay. So next, write sharpness of the resonance. Sharpness of resonance. What is the meaning of the sharpness? We can say. Generally, we are talking sharpness. What is the meaning? What is the literary meaning of the sharpness? Koh kichi bhi koh re, the basucha silently. What do you mean by sharpness? मैं कौन है पेंसिल टा कट करिया पे हमें शार्पनर यूज करछे. What is the meaning of sharpener? to make the pencil narrow. Am I right?
Yes, sir.
Yes, sir.
Okay. So similarly, the sharpness means the narrowness. Okay. Get the curve. The narrow curve is known as sharpness. Okay. So right, it indicates the rapidity. It indicates rapidity with which amplitude decreases. It indicates the rapidity with which amplitude decreases on either side of the resonance frequency. On either side of the resonance frequency. Okay.
Amplitude
decreases on either side of the resonance frequency. On either side of the resonance frequency.
सर
Okay.
आउथर टिके रिपीट कर दे सर
केते आ रिपीट करिबे बाबू एमति पढले वर्ष लागि जिवो सिलेबस सरिबोनी. It indicates the rapidity with which the amplitude decreases on either side of the resonance frequency. Sarla?
यस
Yes, sir.
Okay. You draw this diagram. Already I have done. This is x-axis. This is y-axis. Okay. You plot the graph. One graph is like this. Look here. All of you look. Okay, I want to share. Is it visible or I have to share the screen?
Visible.
Visible, sir.
Okay. Okay. So this middle point you mark as omega naught, which is equal to omega r. And x-axis I have taken omega. This is omega, angular frequency. Y-axis I have taken amplitude. Okay. So first curve you plot like this. You mark it is a sharp resonance. And again you draw second curve. This is moderate resonance. And third curve you draw like this. This is known as flat resonance. Okay. Solana nahi re. Hello.
Sir,
तो शीघ्र करो कौन ते टाइम नबर मु की जान पानी.
Sir, complete.
Complete. Okay. So I have shown you three curve on the same graph. This is, look here, look my pen. So this is flat. The width is more. This is moderate. The width is less. And this is sharp. The width is very less. So this is the width of the curve. This width is very, very less that of this. And this is again less than that of this. Sharpness of the resonance. Flat resonance, moderate resonance, sharp resonance. And this width I have taken del omega. Y-axis, this is amplitude. So this width is known as del omega. That is known as bandwidth or width of the resonance curve. Then after that you write for resonance, omega is equal to omega naught. Omega is equal to omega naught. We know. So if omega, and we know beta is a very small quantity. Very small. Very small means you can say 0.000001, which is very small. If you add a small quantity or subtract a small quantity with a given number, there will be no appreciable change. Understood?
Yes, sir.
Because
Yes.
in
Yes, sir.
science and engineering, we have to take some assumption. Without assumption, the people cannot get the result. Some people raise the question, sir, why Einstein has taken E is equal to mc square in the formula E is equal to mc square? Okay. हाँ शीघ्र कर लिख अरे मैं चला प्रज्ञा
Yes, sir.
okay next लिखा. So since we have what omega is equal to omega naught omega 0 plus beta, let omega 1 is equal to omega 0 plus beta. I have taken let देखा जाउछि तो आउ पड़े आछि गुटे let omega 1 is equal to omega 0 plus beta, omega 2 is equal to omega 0 minus beta. Now you take the subtraction omega 1 minus omega 2. If you take the subtraction, the answer will be how much? Tell me, be quick.
2 beta.
2 beta. Because omega naught plus omega naught and minus omega naught, that will be cancelled. Okay. So let omega 1 minus omega 2, that gives you del omega. Look my diagram. You have to show the diagram like this. So this is the sharpness. Okay. So one part is omega 1, another part is your omega 2. So if you take the subtraction, that gives you del omega. You see the previous diagram. Look here. So let this is omega 1, this is omega 2. You mark, this is omega 1. I have written omega 1. This is omega 1, this is omega 2. So if you take the subtraction, that gives you del omega. Okay? That gives you del omega. So del omega is equal to 2 beta. Are you writing or not? Omega 1 minus omega 2 is equal to omega 1 minus omega 2. Omega 1 minus omega 2 is equal to del omega is equal to 2 beta, where del omega is known as width of the resonance curve or bandwidth. Look, where del omega is known as width of the resonance curve or bandwidth. Okay. One important question is here. Look here. All of you look your expression. Del omega is equal to 2 beta. If beta will be more, del omega will be less. If beta will be more, if beta will be more, del omega will be more. Del omega will be more means this is a flat resonance. If beta will be less, del omega will be less. The width will be less. Then the curve will be more sharp. So now question is how sharpness of the resonance depends upon beta. Who can say the answer? Nobody is saying.
Sharpness of the resonance is inversely proportional to beta.
Very good. Okay, I have written for that you told. Okay, so look the justification. Beta will be less, del omega will be less. So del omega will be less means the curve will be more sharp. So you write if beta is small, then del omega is small. That means more sharp resonance. So this implies sharpness of the resonance is inversely proportional to the damping coefficient. One question MCQ base or 2-mark question, how sharpness of the resonance depends upon damping coefficients. So many students did mistake that del omega is equal to 2 beta, so it is directly proportional. No, it question is sharpness. So sharpness of the resonance is inversely proportional to the damping coefficient. समझ में आया?
Yes.
Okay. So next again you draw another diagram. You draw that diagram in a different way. Y-axis, this is amplitude. X-axis, we have to take omega. Okay. So we have again 3 curves. This is the flat moderate resonance, and this is the sharp resonance. Okay, this part is not. I have. This is not part. This is like this. Okay, resonance omega is equal to omega naught square minus 2 beta square. That means here, why the curve is flat? Beta is high, so flat curve. And for the second one, omega is equal to omega naught square minus 2 beta square. So beta is small, so not so sharp. And for third, it is a sharp resonance. Okay, diagram complete. अरे डायग्राम सरल ना नहीं
No, sir.
এই যেটা কট করা হয়েছে এটা হবনি কেবল এই ভଳିয়া যেমতি সেকড়ে করা হয়েছে সেই ভলিয়া কর
Completed, sir.
Sir? Hmm?
Yes, sir.
अरे all of you are doing or not?
Yes, sir.
Completed? Pragya?
Yes, sir, complete. Yes, sir, complete.
Yes, sir.
Okay. Now question is, so we are we cannot not discuss about flat and moderate since it is sharp resonance. As I said, the definition, it indicates the rate at which the amplitude falls. Okay, so the amplitude will be maximum at resonance frequency. Then the amplitude suddenly decreases as the frequency increases or decreases. So this is my omega r. The middle point omega is equal to omega 0 or which is equal to omega r. So from this omega r or omega 0, how much the amplitude decreases? So this is one question mark. You have to remember the amplitude decreases a max divided by root 2. So you have to measure what is your maximum amplitude. Suppose it is my maximum amplitude. After reaching the maximum amplitude, amplitude suddenly decreases on the left hand side, on the right hand side. How much decreases? One proof is there that is not required as per the new syllabus. You remember the amplitude decreases 1 by root 2 times of its maximum value. You write amplitude falls. The amplitude falls 1 by root 2 of its maximum value.
Sir, 1 by root 2?
1 by root 2, 1 by root 2 times, or 1 by root 2 of its maximum value. Okay? Out another point, right? The faster they fall, the sharper will be the resonance. The faster the fall, the sharper will be the resonance. The faster the fall, the sharper will be the resonance. Okay? Salla?
Yes, sir.
Yes, sir.
Okay.
Yes.
So who can justify this sentence? Soumya, are you there?
Yes, sir.
So last two classes, where did you visit? Where did you go?
Sir, I was attending, sir, my sister's reception, sir.
Sister's reception.
When a reception party, sir, gaya tha.
You have to say reception party. Sister's reception.
Sorry, sir.
Okay. But at that time, you gave the message, sir, I was present but not attendance given.
सर एग्जाम हुआ था इसीलिए सर मैंने एक जगह के बेट में एग्जाम देके सर चला गया सर
ओहो अच्छा अच्छा तो साइमल्टेनियसली दो काम हो गया एक टाइम पे तुमको हेजनबर्ग मना किए थे ना if one will be correct another will be incorrect Hmm?
Yes, sir.
Okay. Okay, somehow you justify the sentence, the last sentence. The faster the fall FALL, the faster the fall. तापर कौन लिखला?
The
The
sharper will
sharper.
be the resonance.
You justify the sentence. The faster the fall, the sharper will be the resonance. Anybody who can justify the sentence? Pragya?
Sir.
The faster the fall, the sharper will be the resonance. How can you justify? Anybody?
एम्पलीट्यूड जितने रेट से फॉल करेगा उतना ही शार्प
Yes,
होगा.
yes, yes. Good. Your name, please? Vikas.
आदित्य.
Aditya, yes, you are absolutely correct. Only he is listening sincerely. Nobody is listening. Okay, मैं तुमको बोले थे ना, the faster the fall का मतलब क्या है? Decrease. So कौन सा फैक्टर डिक्रीज करेगा? एम्पलीट्यूड डिक्रीज करेगा. एम्पलीट्यूड जितना जल्दी से डिक्रीज करेगा, कर्व वही हिसाब से शार्पर हो जाएगा. समझ में आया? यहाँ पे क्या हो रहा है? स्लोली 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 आ रहा है. यहाँ पे स्लोली आ रहा है. यहाँ पे क्या आ रहा है? सडनली डिक्रीज हो रहा है. सडनली डिक्रीज हो रहा है. The faster the fall means decrease. The faster the decrease of the amplitude, the sharper will be the resonance. So sharper means the width will be very less, the curve will be more narrow. Okay, समझ में आया सबको?
Yes, sir.
Yes, sir.
So next is quality factor. लिखो quality factor, QUALITY, quality factor. Quality factor. Quality factor, it is symbolized as Q for quality factor. Okay, so right, it is a measure of sharpness of the resonance. It is decrement measures in case of DHO. So here it measures the sharpness. It is a measure of sharpness of resonance. It is defined as, it is defined as Q is equal to 2 pi into average energy stored per cycle divided by average energy loss per cycle. Average energy stored per cycle divided by average energy loss per cycle. Okay. So derivation is not required. The Q factor is equal to, so this is 2 pi times, after doing the derivation, you can find Q is equal to omega naught divided by 2. Okay, we know at resonance omega naught is equal to omega r. So omega r by 2 beta. So this is omega r. 2 beta is equal to del omega. Just today I told you, 2 beta is equal to del omega. Okay. So omega r by del omega, or I can say Q is equal to what is omega r? Resonance angular frequency divided by width of the resonance curve. What is the del omega? Width of the resonance curve. Okay, width of the resonance curve. Okay.
Yes, sir.
Okay. So प्रज्ञा एक बार रीड करो क्वालिटी फैक्टर. प्रज्ञा, प्रज्ञा, अरे हेलो ऋतुराज,
Yes, sir.
रीड करो क्वालिटी फैक्टर.
It is a measure of sharpness of the resonance. It is
Okay.
defined as Q is equal to 2 pi into average energy stored per cycle divided by average energy lost per cycle. Q is
Okay.
equal to W naught by 2 beta equal to WR by 2 beta equal to WR by del omega, or Q equal to resonance angular frequency divided by width of the resonance curve.
Very good. So that is not a W. You can read as omega R. Okay. That is omega. Okay. So write one problem. In a forced oscillator, resonance frequency is 500 hertz. Resonance frequency is 500 hertz, and the damping coefficient is 2 second. What is the unit of the damping coefficient? What is the unit of the damping coefficient? Who can say?
Second.
What is the unit of the damping coefficient? Second inverse. 2 second inverse. Find quality factor.
Sir, out 3 question ta.
तमे को दुनिया रे अच्छा बे प्रज्ञा? प्रज्ञा? प्रज्ञा?
Sir, Pragyan ho
Ine-
Suryam.
सूर्यमय को दुनिया रे अच्छा?
Sir, na net
ତିନି ଥର
ଟିକେ
ଡାକିଲା
problem
ପରେ
ଅଛି.
ତମେ ଜବାବ ଦଉଛ?
Sir, up down ଅଛି. Net.
ମୁଁ ତିନି ଥର ଡାକୁଛି କି ନାହିଁ ସାର୍, ମୁଁ ପ୍ରଜ୍ଞା ନୁହେଁ, ମୁଁ ସୂର୍ଯ୍ୟମୟୀ। ଲେଖ, in a forced oscillator, resonance frequency is 500 hertz. The damping coefficient is 2 second inverse. Find quality factor. Okay, लिख लो सूर्यमयी।
Resonance frequency is 5 hertz.
The damping coefficient is 2 second inverse. Find quality factor.
The quality factor is 125. 25.
Name please.
Aditya, sir.
Aditya. Okay. Tell me, Aditya, how you have done?
Sir, Q is equal to omega R upon 2 beta.
Very good.
So we are given that omega R is 500 hertz, then beta is 2 second inverse.
Yes. Yes.
So after doing calculation, we get to 125. Q is equal to 125.
That means 500 divided by 2.
2 into 2, sir.
Huh?
2 into 2. 2 beta, no, sir?
How much? 500 divided by 4.
Yes, sir.
So 500 divided by 4 is how much?
125.
125. Okay, let's check. Okay, good, Aditya. But your answer is wrong, but you tried.
Sir, 250.
Okay. 250. Okay, who told?
Sir,
Name,
Kumar
please.
Chidambaram.
Kumar Chidambaram. Okay. So now tell me, Chidambaram, please read the question again.
Sir, in a forced oscillator, resonance frequency is 500 hertz, and the
Okay,
damping.
take a break. In a forced oscillator, resonance frequency is 500 hertz. So which one is given?
FR.
F. Okay, very good.
FR, sir.
FR resonance, जहां तक angular का term use नहीं है, you have to consider that is linear. Many times last class also I told you. यहाँ पे कोई जगह में angular का term लिखा नहीं है. So it is FR is given. So write given FR is equal to 500 hertz. Next, Chidambaram. Next, you read the question.
Sir, the damping coefficient is 2 second. 2 second inverse.
Yes, that means beta is given 2 second inverse.
Yes, sir.
Okay. Beta is equal to 2 second inverse. Okay. Okay. So in our question, FR is equal to
0.2 only 2, sir.
FR is equal to this 500 hertz. Okay. Beta is equal to 2 second inverse. We have to find quality factor. What is the formula? Chidambaram, quality factor is equal to
Omega R by 2 beta.
So क्या लिखेंगे अभी यहाँ पे क्या लिखेंगे बताओ जल्दी.
सर मु 2 बीटा को डायरेक्ट 2 नहीं जाइछि.
ठीक है तुम बताओ ना.
500 by 2. ये 500
ओमेगा आर के जगह में क्या लिखेंगे यहाँ पे
2 pi f.
2 pi f. वेरी गुड. आदित्य अभी समझ में आया.
डिवाइडेड बाय 2 बीटा.
डिवाइडेड बाय 2 बीटा.
Yes, sir.
So 2 to cancel because तुमको ओमेगा नहीं दिया है f दिया है. So ओमेगा
Yes,
इज इक्वल टू 2 pi f. 2 to cancel. पाई का वैल्यू कितना है पाई
3.1
by beta. So this is equal to pi is equal to 3.141. f का वैल्यू है 500 डिवाइडेड बाय 2. ओके ये सॉल्व करके जितना हुआ बताओ कितना हुआ 250 इंटू 3.141 कितना हो रहा है. जल्दी देखो मुझे फिर कैलकुलेटर करना होगा. कितना हुआ 250 इंटू कितना बोलो जल्दी बोलो
785.25.
Yes, this is your answer. 785.25. This is the value of quality factor.
785.2.
हाँ 785.25. क्वालिटी फैक्टर का क्या यूनिटी होगा कुछ यूनिटी नहीं होगा
यूनिटलेस.
क्योंकि ना ये तो सेकंड इनवर्स ये सेकंड इनवर्स कैंसिल हो जाएगा. ठीक है ना. ओके यूनिटलेस. इट इज ओनली ए मेजर ऑफ दिस हार्पनेस ऑफ द रिजोनेंस. ये मेजर करेगा उसका कोई यूनिटी नहीं है. सो ये दिस टाइप ऑफ क्वेश्चन यू विल फेस ऑन योर एग्जामिनेशन 2 mark क्वेश्चन. So be careful whether linear frequency is given or angular frequency is given. Okay. So accordingly you will give the answer. You will apply on the formula. Okay. So this is all about your resonance. अच्छा तुम्हारा coupled oscillation हुआ था क्लास में ना नहीं. अरे जल्दी बोल. अल्प पढ़ाई
मेरा
था.
कंप्लीट ही नहीं.
Okay. So now you got some idea about resonance, sharpness of the resonance, quality factor.
Yes, sir.
Okay. So next you write give as heading coupled oscillation. COUPLED. coupled oscillation. coupled का मीनिंग क्या है बताओ ना.
पेयर.
What is the pair? Very good. Pair means 2. Okay. So in case of simple harmonic, damped harmonic, forced oscillation, we have taken a single body. मैं कहाँ पे 2 बॉडी कंसीडर किए थे क्या.
नो सर.
always we have taken a single body. उसका हम डिफरेंशियल इक्वेशन सॉल्यूशन ये सब चीज दिखा है. बट यहाँ पे कपल्ड ऑसिलेशन में क्या होगा मोर देन 2 बॉडीज. सो क्या होगा ना इफ यू टेक 2 or more bodies oscillate in a such a way that the oscillation of one influence the oscillation of the other. सपोज मैं क्या यहाँ पे देखो मैं एक एग्जांपल देता हूं. ये हम 2 बॉडी लिए हैं एक A and B. Is it visible? Body A,
Yes,
body body B, both are connected by a spring. This is the spring. Body A is also connected by another spring. Body B is also connected by another spring. So यहाँ पे क्या होगा ना, ये body A oscillate होगा, if you oscillate body A, then due to A, body B will oscillate, and vice versa. If you oscillate B, body A will oscillate. So this resultant oscillation is called as coupled oscillation. समझ में आया? The resultant oscillation is called as coupled oscillation. Okay?
Yes, sir.
Okay. So just 1 minute. So write the definition. When two or more bodies are connected by a spring, two or more bodies, ना सेटा काटी दिए, connected लिखा दरकार नहीं, लिखी सरानी?
सर लिखी सारूँ
Yes, sir.
हाँ ठीक है. When two or more bodies are connected by एटा काटी दिए, by spring and oscillation of one influences the oscillation of other. Oscillation of one influences the oscillation of other, then the resultant oscillation is called coupled oscillation. The resultant oscillation is called coupled oscillation. Okay?
Yes, sir.
yes.
Yes, sir.
आदित्य एक बार रीड करो डेफिनेशन. आदित्य,
When two or more bodies are connected by strings and oscillation of one influences the oscillation of other, then the resultant oscillation is called coupled oscillation.
yes, then the resultant oscillation or combined phenomenon is called as coupled oscillation. Then you draw this diagram. This is the rigid support. This is the spring connected by spring, body A. This is another body. This is body B, which is connected
So
by
it
a
is not
rigid
clearly
support.
visible.
Huh?
No, sir. It is visible now.
Okay, 1 minute. Is it visible now?
Yes, sir.
Yes, sir.
Yes, sir.
So this is the spring. It is known as a spring. This is body A connected by another spring, body B, then this is third spring. Okay? So these are the examples. Example. So right, two bodies are connected by two bodies are connected by three springs. Number 2, two coupled LC circuit. Two coupled LC circuit. What is LC circuit?
Inductance,
कंडक्टर और
capacitance.
कैपेसिटेंस.
Very good. So in case of LC circuit, if you make a circuit having inductor and the capacitor, due to one, another will oscillate. Okay, that is your coupled oscillation. The third one is, likho, two simple pendulums are connected by a spring. Two simple pendulums are connected by a spring, S-P-R-I-N-G. Two simple pendulums are connected by spring. Okay, complete?
Yes, sir.
Yes.
Okay. So these are the examples of the coupled oscillations. I told you three examples. Okay. So in each case, what will happen? One body, one will influence the oscillation to other. Okay. Okay. So now, as per your syllabus, we have to discuss what? We have to discuss one example. You give the heading as coupled system of two pendulums. देखो, coupled system of two pendulums. Coupled system of two pendulums. Out of three examples, as per your syllabus, we have to discuss this. Okay? Have you written the heading?
Yes, sir.
Yes, sir.
Yes, sir.
Coupled system of two pendulums. Okay? So you draw this diagram. I shall then explain. Sallah?
Yes, sir.
Okay. Look, this is a rigid support. Okay? This is the string. This part is known as a string. S-T-R-I-N-G. Okay? So this is the string. L be the length of the string. One, this is the bob. This is known as bob. B-O-B, bob. Okay? Or we can say simple pendulum. Okay? So one bob is hanged from a rigid support by a string. And this is the second bob. And both A and B are identical. Identical means same mass. And the length is also same length. Okay? Both the bobs are attached by a spring. This is the spring having constant K. So what will happen? If you oscillate bob A, the B will oscillate and vice versa. Let the bob A move a distance of x towards left hand side, making at an angle of theta. This is the theta. Similarly, body B also moves along right direction with a distance y, making at an angle of theta. Okay, complete.
Yes, sir.
Everybody complete or not?
Yes, sir.
Yes,
Okay.
sir.
So that thing we have to write. Let us consider right. Let us consider two identical.
Sir, voice break हो रहा है.
Let us consider two identical pendulums Am I audible now?
Yes.
Yes, sir. Yes.
Yes, sir.
Let us consider two identical pendulums A and B, each of mass m, suspended by a rigid support, suspended by a rigid suspended by a weightless string of length L,
Sir,
suspended
suspended by the rigid support.
by suspended by a weightless string weightless string of length L from a rigid support. Two bobs are attached by a spring. Two bobs are attached by a spring of spring constant K. Two bobs are attached by a spring of spring constant K. Let X and Y be the displacement of two pendulums. Be quick. Let X and Y be the displacement of two pendulums. X and Y be the displacement of two pendulums A and B respectively. Okay, Aditya, सौम्य रीड करो कौन लिखिल
Sir, मूलरू ना एबे जो last line.
नहीं मूलरू पढ़ो
Let's consider two identical pendulums A and B, each of mass m, suspended by a weightless string of length L from a rigid support. Two bobs are attached by a spring constant K. Let X and Y be the displacement of two pendulums A and B respectively.
Okay, that means let X and Y be the displacement of the two pendulums. Okay, you see your diagram. Okay, now what will happen? There will be two forces will act on each pendulum. Okay, so right, two forces will act on pendulum A and B. Two forces will act on pendulum A and B. What are the two forces? Number one, restoring force on pendulum A. As you know, in case of simple pendulum, there will be restoring force. Restoring force on pendulum A is minus K into X minus Y. Next, restoring force on pendulum B is minus K Y minus X. Sala?
Yes, sir.
Next, number two, gravitational force on pendulum A is, one will be restoring force and another one will be gravitational force. Gravitational force on pendulum A is minus mg sine theta Who can say so why it is minus mg sin theta? Anybody who can explain this? How it is mg sin theta? Look here, I am explaining here. This is the bob. Look our diagram. Okay, the diagram. You see.
So it is the
Yes.
vertical component of
Gravity
mg.
restoring force लिख दिए ना. Restoring force is minus kx x minus y on pendulum B is minus k into y minus x. So look here. This is the pendulum. The weight of the pendulum is equal to mg. You know weight is equal to mg. The mg resolved two components here. One is mg cos theta along this direction, mg sin theta along this direction. Mg cos theta and tension of the string both are equal, but direction opposite. This is the tension of the string, this is the mg cos theta. So both will balance, both will clear, cancel. So we have only mg sin theta. We have only mg sin theta. So due to this mg sin theta, the pendulum is moving from this point to this point. Okay. If there will be no mg sin, there will be no sin theta. Sorry, there will be no mg sin theta. The pendulum does not return back. Okay. So theta be the angle here. Okay. Now tell me what is your sin theta for pendulum A? Who can say sin theta? Look your diagram. The distance is x. This is L. This is the theta. What is your sin theta?
X by L.
X by L. If you see, it is a right angle triangle. Very similar. It is a right angle triangle. Okay. So sin theta is equal to P by H. Okay. So we can take X by L. Okay. Similarly, in pendulum B also, this is Y by L. Y by L. Okay. P by H. So, right. Gravitational force on pendulum A is minus mg sin theta, which is equal to minus mg into x by L. Similarly, gravitational force on pendulum B is minus mg sin theta, which is equal to minus mg y by L for pendulum B. A के लिए x by L, B के लिए y by L. Okay, समझ में आया?
Yes, sir.
Yes, sir.
Now I am going to find what is the differential equation. So differential equation means we have to find separately for two pendulum A and B. First, we have to find differential equation for pendulum A. So to do this, already we have done in case of simple harmonic, damped harmonic, forced oscillation. The total force, like a total force act on pendulum A is, what is the total force? F is equal to restoring force plus gravitational force. ଲେଖୁଛ ନା ନାଇଁ ରେ? Hello.
Yes, sir.
Yes, sir.
So total force act on pendulum A is Fr plus Fg. Force is equal to mass into acceleration. What is your restoring force? Minus k into x minus y. ନାଇଁ କି? ଏଠି ଆମେ ଦେଖିଛେ minus k into x minus y. What is your gravitational force? Minus mg into x by L. Minus mg into x by L. Okay. Okay. Acceleration in terms of displacement. This is d square x by dt square is equal to this. Now you divide m throughout the equation. So d square x by dt square plus k by m x minus y plus g by L into x is equal to 0. So bringing the right hand side into the left hand side, dividing the equation by m. So next step is d square x by dt square plus k by m x minus y. What is g by L? G be the acceleration due to gravity. What is L? Who can say? What is L? L be the What is L we have taken? Length of the string. Bob means length of the string. Okay?
Length of the string.
Because my battery is close to end.
Length of the string.
Screen again screenshot नहीं जाओ पहले. এটা ରଖିଥିଲି କି ଆଜି ନେଇଯାଇଛି ଏଠି ଲ୍ୟାବରୁ ଆସିକି ଚାର୍ଜରଟା ଥିଲା ଏଠି.
ले लिया सर स्क्रीनशॉट.
जल्दी जल्दी ले जाओ स्क्रीनशॉट.
हो गया सर.
Okay. So only to I want to okay. How many times left?
Sir, 2 minutes
minutes,
only, sir.
2 minutes.
Okay. Okay. Is it visible?
Yes, sir.
Yes, sir.
Okay. So G is constant, L is constant. So the ratio gives you new constant. So the new constant is equal to how much? That I have taken omega 1 square. So d square x by dt square plus k by m x minus y plus omega 1 square x is equal to 0. Okay, where omega 1 square is equal to g by l. And okay, so this you give, this is equation number 1, which is for pendulum A. D square x by dt square plus k by m x minus y plus omega 1 square x is equal to 0. You give equation 1. This is for pendulum A. Okay. Similarly for pendulum B, similarly for pendulum B, you arrange those who has taken the screenshot. Ken is the screenshot.
गुप्तेश्वर.
Gupta you share. You send me. You send me.
हाँ सर फिजिक्स ग्रुप में सेंड कर दिया है.
Okay, ठीक है. So similarly for pendulum B, क्या होगा बताओ? ये पेंडुलम A के लिए हो गया. पेंडुलम B के लिए क्या होगा? X के जगह में Y पुट कर देंगे. वही सेम चीज, रिस्टोरिंग फोर्स प्लस ग्रेविटेशनल फोर्स. यहाँ पे माइनस के वाई माइनस एक्स हो जाएगा. यहाँ पे माइनस एम जी वाई बाई एल हो जाएगा. मैं आई हैव रिटन द फाइनल एक्सप्रेशन डी स्क्वायर वाई बाई डी टी स्क्वायर प्लस के बाई एम वाई माइनस एक्स ओमेगा 1 स्क्वायर वाई इज इक्वल टू 0. दिस इज इक्वेशन नंबर 2. अरे लिखो यार. हेलो.
यस सर,
Yes,
कंप्लीट.
sir.
Yes, sir.